Okay, so now let's look at the division aspect of this. What are we going to do now? Well, with division, we have to follow a little bit of a different set of rules. And so this is called the quotient rule, and you're going to hear it a lot, just like with the product rule from the previous slide. So one thing we need to make sure of is if we have some function divided by another, that bottom function, it cannot equal 0. If it equals 0, we can't do anything because at 0 in a fraction we are undefined. So what we're going to do is we're going to look at this function, divide it by another function, and we're going to use this rule where it's kind of complicated and weird looking, but we're going to like take v times the derivative of u minus u times the derivative of v all over v squared. And so that's what this guy looks like. There's a couple of other ways to think of this problem, which may or may not help you. We could look at it as v times u prime minus u let's get rid of that guy, u times v prime all over v squared. This is one way we could look at it. Or we could look at it this way, and it's the same thing, but it's a little bit different. It would be something that we would call low d high minus high d low all over low, or low squared. Okay? And these are the two different ways maybe that you might be able to remember how the quotient rule works. So it's a little bit challenging, quotient rule is, but after you've practiced it and done it and worked on it and looked at it and messed with it, it does get a lot easier to do. And compared to some other things that we're going to do in calculus, this actually isn't so bad. So we want to find the derivative of x squared minus 1 over x squared plus 1. And how do we start that? Well, we're just going to remember that on top is u and on the bottom is v. And I'll tell you what, I'll make that v a different color so that we can see a pattern here. So we'll make v this color right here, v. So I've got u on the top. So how's this going to work? Well, u on top, v on bottom. I'm going to take low, so f prime is equal to low. That would be x squared plus 1. And always use parentheses, or else you're going to have an error. So low d high, that means the derivative of the top, which is 2x, minus high, okay, and then again parentheses, and that's going to be x squared minus 1. D low. D low is going to be 2x all over, whoops, I want black ink for that part, so we'll just get the black ink part here, all over the low man squared, low. So x squared plus 1 squared. Now, you've done most of the work. However, you're not finished. We have to clean up the top. So on the top, I'm going to have 2x cubed plus 2x. That's the left-hand side of the top. Minus, and then on the right-hand side on the top, in parentheses. Don't forget those. You're going to have 2x cubed minus 2x. And so this is what you've got going on the top. Well, now let's combine together all the things that are the same. So on the new problem that we're going to end up with is 2x cubed minus 2x cubed is 0. Easy enough. Plus 2x plus 2x is 4x, not 4x squared. Okay, that's a very common mistake. It is not 4x squared, it's just plain old 4x. Why? Because if I have 2 x's and I add 2 more x's, I've got 4 x's, and that's what we're dealing with on the top. On the bottom then, you don't necessarily need to square this out. You certainly are more than welcome to do so. Don't make an error in the process, but x squared plus 1 squared is fine because nothing reduces. So this is using the quotient rule. It is a little challenging at first, But after you've worked on it and noticed what these patterns are, it does get easier to do.